Okay. So compound interest and other models, we're starting off with compound interest. And I just want to bring you back to a formula that we talked about a couple of weeks ago, and that was where we took simple interest. And then we added it back on. So simple interest is where we have some principal balance, it's usually called P, and we have some interest rate, and then we have some time that goes by. And if we take that interest and we add it back on, we get some new future amount. And the new future amount is going to be whatever we started with. So A is the future amount, P is what we started with, and then we add on our interest. And our interest is what I have above. So that would be the PRT. Okay. So we played with this formula in lesson 3.7. You saw it again on the test, and it turns out to be a very, very important formula because this is what's going to carry us into compound interest. Now, this right here, this formula for adding the interest back onto an account is the slow way to do it. And you know, there's nothing wrong with slow ways. When I build stuff, I'm slow. When I grade, I'm slow. When I do math, I'm slow. But I build good things and I do good math. But sometimes there are some better ways, and it turns out there is a better way here. We learned how to factor this thing right here. Because there is a common P here and here, we can factor that out. And if you remember, what that looks like is this. The P popped out, and we ended up with a parentheses. Where the first P was, we get a 1. And where the second PRT was, well, we took the P away, so it's just an RT left. Okay, so this is a slightly different version of that formula above. I'm gonna circle that one with green. Whoa. This right here is the faster way. Oh, where's my pen? There it is. Of calculating interest and putting it back in the account. It's also more efficient. And we're going to play with this idea today and see how it differs from simple interest. And I'm also going to break this down in a spreadsheet because a spreadsheet is a great place to do financial calculations that are repetitive. And this is going to be very repetitive in the way we do the calculations. So this formula here is going to be super important to us. And let's see, how do I get a new page on this thing right there? No, that was not a new page. I know there's a button for it somewhere. That one? Yes, okay. Sorry, this is a different whiteboard than I usually use. Oh, I'm having mouse issues now. Where's my mouse? There it is, okay. Let's erase that and try again. All right, so we have this new formula. And it goes A is equal to P times parentheses 1 plus RT. And just a reminder about what these mean here. This is going to be super important, and we're going to see this over and over again this week, and it's going to come up again and again for the rest of the term. A is some future amount. P is some principal amount, present amount, often called the principal. So I'm going to call it either the present amount or sometimes it's known as, AKA, also known as principal. Principal, not principal, like the guy at your high school that was in charge. Then we have R. R is an interest rate. And it is usually a yearly rate. And this is going to be important. It's also known as, AKA, an annual percentage rate. Oops. Rate, there we go. And annual percentage rate, I'm going to abbreviate often as APR. Okay, so that's annual percentage rate. And time is the T. So we have T. Time is usually in years, but it could be months, could be days. Just kind of depends on the problem. So I'm going to give you a jump start on the lesson, and then I'm going to push you guys off into groups to double check answers with each other. But we'll get it pretty much roughed out. So all you have to do is fill in a few blanks, but you'll have most of it done. So again, this is the formula we're going to play with. Now what we're going to do is we're going to watch this change over time. Right, so I put some money in an investment account. Maybe it's a certificate of deposit like you read about in the prep, but it could be a lot of other things. A savings account, some stock investment. Now stock investments don't usually have a fixed rate. Certificate of deposits do have a fixed rate, and most savings account have a fixed rate. Makes it easier to calculate. The rate's not fixed, then we have to redo things every month, which is kind of a pain. But if it's the same rate every month, we can automate it. All right, so let's play around with some time. So I'm going to make a little table here. And we're going to keep track of years gone by. We're going to keep track of, let's just jump straight to the total amount. And to calculate that amount, remember we have our formula, A equals P times 1 plus RT. We're going to do the fast way instead of the slow way. Sometimes you got to do the slow way, but sometimes the fast way is nice. I'll show some examples of why we might want to do the slow way instead. I'm going to put a year 0 in here. So that means I'm like trying to get something started. Like I go to the bank and I say, hey, I need to invest some money so it's worth more in the future. And they say, hey, how about a certificate of deposit? And they say, we'll give you an APR of 2%. Okay, so that means at the end of every year, they'll take whatever money I have in my account and they'll add on 2% to it, right? So I'm making money on money just sitting there. So my initial amount, like I got to give them some money. So let's say I've got $1,000 to invest. So my initial investment is going to be $1,000. 0 time has gone by. So if I were to plug that information in here to double check with the formula for 0 years, I would get P is 1,000 times 1 plus 2% as a decimal, right? Be 2/100ths times 1 year, 0 years, right? I'm just giving them the money. No time has gone by. Well, 0 times 2 is 0, right? 0 plus 1 is 1. 1 times 1,000 is still 1,000. Okay, I could double check with my calculator and it will agree with me. And often in financial matters, we do start off with a 0 year. And then we move on to the next year. So 1 year later, what's going to happen? Well, the bank's going to apply this formula up there, and they're going to say, all right, you had $1,000 sitting in the bank all year long. So we're going to take it and multiply it by 1 plus 0. Let's see, 0.02 is my percentage rate, and 1 year has gone by. Right? Cleaning that up a little bit, just going to switch colors. That would be 1,000 times, well, 1 times 0.02 is 0.02. Add that to another 1, and I get 1.02. So then I whip out my calculator. So you guys got a calculator handy. I'm going to go grab my scientific calculator here from Google. I want to know what is 1,000 times 1.02. And Google says it is $1,020. That sounds about right. And it's showing me what I typed right above there. All right, so back to the notes. So now, let's put that in green. We know that at the end of year 1, we now have $1,020 just for letting our money sit there. And then another year goes by. So another year goes by, so this is the second year. The bank says, hey, you've had $1,020 sitting in the bank for a whole year. So they take that and they multiply it by 1 plus 0.02 times yet another year, right? Now, I am in year 2, but it's been 1 year since they made the last calculation. And that's what this t right here is, how much time has gone by. It's been 1 year. Cleaning that up a little bit, I'm going to get the 1,020 times 1.02, just like before. Now, because I have more than 1,000 to put interest on, I should be a little bit better off. So let's check with the calculator. So I asked the calculator here, what is 10, oops, I gotta click up there, 1020 times 1.02. Calculator says you now have $1,040.40. So let's put our money in green that we've earned. So this is our new amount, $1,040.40. So with just simple interest, I would have gotten only $20 a year. Now I get an extra 40 cents because my $20 collected interest too. And that's what compounding means. Your interest collects interest, okay? It compounds, it doubles up. All right, let's do this one more time and then we'll try to find the pattern here because there's a pretty cool pattern. So then year 3 comes along. And what happens? Well, the bank looks and says, hey, you've had $1,040.40 in the bank all year long. So they're going to run their calculation. And that calculation is the same as before, right? They're going to do exactly this, which led to that. So I'm just going to jump right to that part right there. So they're going to have, they're just going to take that, multiply, oops, that's a highlighter. Sorry about that. I want a pen. And pen, let's do red. They're going to multiply by that 1.02. And then that's going to give me a new amount. And so I should go ask my calculator what that new amount is going to be. And then we'll see if we can identify the pattern here. So I have this amount, which I'm going to now multiply by 1.02. And I didn't need to retype it because my calculator already had it there. Sometimes you have to use the previous answer button on your calculator, which saves mistyping stuff. Okay, so now the bank has the option to not round that up. They could just call it 20 cents, but they're probably going to round it up because they're so nice. So I would now have $1,061.21. Excuse me. All right, so microphone, there we go. Now again, if this was just simple interest, I would simply get 20 bucks a year, nothing more. But my interest is collecting interest, and so in year 3, I don't just have 20 plus 20 plus 20, which would be 60, I have 61.21. So my interest is making me some more money. Now it's not a lot right now, but it's gonna add up over time. All right, so next we're gonna look for the pattern. And the pattern is like wicked simple and almost not even obvious, but the bottom line is every step here, we multiplied by the same result, 1.02, 1.02, 1.02. So another way to think about line 3 here, let's put it in red. To get this line 3, I multiplied by 1.02 3 times in a row. Now, so right, I'll highlight these, color code them. So let's use this first one right here is this one right here. And then let's use green. Here's my second one there. That's this one right here. And then let's maybe throw some orange at this. Excuse me. And so this last one right here is that one right there. And each of those are compounding, right? They're repeatedly multiplied with that starting $1,000. So we're just going to double check this on the calculator. That another way to get this $1,061.21 is to start with $1,000 and then repeatedly multiply that by that 1.02. So whip out a calculator. Let's see if this actually works. We'll talk about a shorthand, look at one more example, and then we're going to dive into the lesson. So if I start with 1,000, and then I multiply by 1.02, and multiply again by 1.02, and multiply a third time by 1.02, I should get exactly that $161.20.8, right? Or we're going to call it 21 cents. So that faster way of adding interest back on really helps us in coming up with a shortcut for compound interest. Now, there is actually another shortcut I could apply here. Isn't there an easier way to write multiply by the same number over and over again? Like, what could I do instead here? Instead of 1.02 times 1.02 times 1.02?
1.02 cubed?
Yeah, to the third power, right? Power means multiply, put that as the base, 3 times. So a shorter way to write this, and let's put that in green, because this is the meat of the day right here, the dessert maybe. Yeah, so that's the short way to write this. And the cool thing about it is, as at first, I had to do this 1 year at a time. But now I think I have a way to just dive to the 10th year. Like, I want to know, what am I going to have in 10 years? What am I going to have in 20 years? I don't have to do every single year in between. What I could do instead is just take this idea right here. If the third year had the third power, right? Third year, third power, then it seems reasonable that the 10th year should have the 10th power. And I don't have to do year by year compounding. I can just jump straight to a prediction for the 10th year, which is kind of cool. And this is the essence of what compound interest is right there. It's an exponential equation because the only thing that's changing here is the exponent. So if I rewrite some of these other ones, I'm going to put this on a new page. So another way to think about this, if I look at year versus the future amount, then in year 0, I started off with my 1,000. In year 1, I have whatever the result of 1,000 times 1.02 is. In year 2, it would be 1,000 times 1.02 to the second power, because we're repeatedly multiplying by 1.02. In the third year, it's 1,000 times 1.02 to the third power, and so on. So the point here, this is called an exponential equation because here's my independent variable there, and I could put a 1 there and it wouldn't change anything. Here's that same independent variable there. Okay. So this is an exponential equation. It's an exponential equation because the exponent is the only thing changing. 1, 2, 3, and so on. If we then kind of generalize and say, okay, let's put a variable for the year. Let's let the year be t. And my formula would just be 1,000 times 1.02 to the power t. So we're going to do one more example of this that's relevant to the lesson, and then I'm going to put you into the lesson. Although I'm sure some of you are simultaneously working on it. All right, questions on this example? Nothing in the chat. Don't hear any voices. Okay.
What section is this?
This is 4.1. All right, so oops, what did I do? I paused the share somehow. How did that happen? I want to stop